A glass rod of diameter d1 equals to 1.5 millimeters is inserted symmetrically into a glass capillary with inside diameter d2 equals to 2.0 millimeter. Then the whole arrangement is vertically oriented and brought in contact with the surface of water. To what height will the water rise in the capillary? Solution. The shape of the meniscus will be cylindrical. Hence radius of the cylindrical meniscus r2 minus r1 and hence diameter equals to d2 minus d1 by 2. The pressure in the meniscus equals to p0 minus 2 alpha y under in the bracket d2 minus d1 by 2 equals to p0 minus 4 alpha y d2 minus d1. Hence the pressure difference with flat surface equals to p0 minus in bracket p0 minus 4 into alpha by d2 minus d1 equals to 4 alpha by d1 minus d2. This is the pressure as a result of which it will rise up. Hence 4 alpha by d2 minus d1 equals to rho into g into h. Hence h equals to 4 into alpha by d2 minus d1 into rho into g. Two vertically plates submerged partially in a wetting liquid form a wedge with a very small angle delta phi. The edge of this wedge is vertical. The density of the liquid is rho. Its surface tension is alpha. The contact angle is theta. Find the height h to which the liquid rises as a function of the distance x from the edge. Let d equals to distance between the two plates equals to x sine del phi. Since del phi is very small, hence d equals to x into del phi. Also let r equals to radius of meniscus, which is cylindrical in this case. We have d by 2 by r equals to cos theta. This implies r equals to d by 2 cos theta. Now we know that the pressure just below the meniscus is less than the pressure just above it by an amount equal to alpha into under bracket 1 by r plus 1 by r dash, where r and r dash are the radii of the two curvatures at right angles to each other. Since the meniscus is cylindrical, one radius is equal to radius of cylinder and r dash equals to infinity because of flat surface. Hence excess pressure equals to alpha by d by 2 cos theta equals to 2 alpha cos theta by d. We know that the liquid column will rise up in between the two plates until the hydrostatic pressure due to it becomes equal to 2 into alpha into cos theta by d. Let if h is the height up to which the liquid rises, then we have h into rho into g equals to 2 alpha cos theta by d. This implies h equals to 2 alpha cos theta by rho into g into d. Or finally we get the value of h equals to 2 into alpha into cos theta by rho into g into x into del phi. Answer. A vertical water jet flows out of a round hole. One of the horizontal section of the jet has the diameter d equals 2.0 millimeter, while the other section located L equals to 20 millimeter lower has the diameter which is n equals to 1.5 times less. Find the volume of water flowing from the hole each second. Let v1 equals to velocity of water in jet of diameter d and V2 velocity vector in jet of diameter d by n. Applying continuity equation a1 v1 equals to a2 v2. This implies pi by 4 d square into v1 equals to pi by 4 d by n whole square into v2. This implies v2 equals to n square v1. Now applying Bernoulli's equation, we have 1 by 2 rho v1 square plus p1 plus rho gl equals to 1 by rho v2 square plus p2. This implies 1 by rho under bracket v1 square minus v2 square equals to under bracket p2 minus p1 minus rho into g into l. This implies 1 by 2 into rho into under bracket v1 square minus n to the power 4 v1 square equals to under bracket 2 alpha by d by n minus 2 alpha by d minus of rho gl equals to 2 alpha by d into n minus 1 minus rho gl. This implies v1 square into under bracket 1 minus n to the power 4 equals to 4 into alpha by rho into d into under bracket n minus 1 bracket close minus 2 into gl, or under bracket n to the power 4 minus 1 into v1 square equals to 2 into g into l minus 4 into alpha into under bracket n minus 1 by rho into d. So finally we have v1 equals to under root 2 into g into l minus 4 into alpha into under bracket n minus 1 by rho into d whole divided by n to the power 4 minus 1. Hence q equals to, hence rate of flow equals to a1 v1 equals to, this implies q equals to pi into d square by 4 under root 2gl minus 4 into alpha into n minus 1 by rho into d by n to the power 4 minus 1. Putting all values, we get q equal to 0.9 cm cube per second. Answer.